Solve the radical equation. The square root of x minus 1 plus 7 equals 2. Anytime I solve a radical equation, I want to get so I have nothing but the radical on one side of the equal sign. So that means the first thing I want to do is get rid of this plus 7 that's not in my radical. I undo a plus 7 by subtracting 7 on both sides. When I subtract 7 on both sides, that leaves me with my radical of the square root of x minus 1 equals negative 5, because 2 minus 7 is negative 5. Now, to undo my radical, to make that go away, I want to multiply both sides of my equal sign by whatever my index is of this radical. So when I don't see an index written, I know that means that it's an index of 2. So that means I want to square both sides of my equation. So I'm squaring my left side, I'm squaring my right side. When I square both sides, my square root cancels out my square, which leaves me with just this x minus 1 that was inside my radical. And on the right side, when I have negative 5 squared, I get 25. Now I need to get x all by itself, so I have to undo minus 1 by adding 1 on both sides. And when I add 1 on both sides, I get x to equal 26. Anytime I have a solution when I'm solving a radical equation, I have to check my solution to make sure that this value that I get actually does work. Sometimes it will not. So going in, I'm going back to my original equation, and I'm going to substitute in this x that I found. I found x to be 26, so I substitute 26 in for x. I now have the square root of 26 minus 1 plus 7. I want this to equal 2. Simplifying, underneath my square root, 26 minus 1 is going to give me square root of 25 plus 7. Now, continuing to simplify, the square root of 25 is 5. I need 5 plus 7 to equal 2. When I do 5 plus 7, I get 12. That does not equal 2, so therefore this is not a solution. We call it an extraneous solution. So we got x to equal 26 over here, solving this correctly, but because it does not work out, it's called an extraneous solution.